All right, so this week, what we're looking at in the support course for Math 340 is interpreting graphs. Specifically, we encounter a couple of examples throughout chapter 2, a few examples, where we have to do something involving derivatives, where all we have to go on is the graph of a function. And in order to do that stuff, you kind of have to know how to read graphs. You have to know how to extract information from them. So that's kind of what we're going to be doing here. We're not going to be doing any problems that specifically ask for a derivative, but we will be seeing some examples that ask for slopes of tangent lines, which is what a derivative technically is. So there is a connection there. But hopefully this section will help with some of those graphical problems that we're seeing in the parent course. This is not going to be a super long lecture because there's not a whole lot to really even talk about with this, but we have a variety of problems that we're going to try and attack. So this is the graph of some function y equals f of x. And if you notice, it's got some weird stuff going on. There's like a horizontal line that's part of the graph. There's a point that seems to not be connected to any of the curves. There's a thing that looks kind of like a parabola, and then a couple other lines, something that looks like a semicircle, and then one more line. So what we want to do is answer some questions just by reading what we see on this graph. Starting with this, what is f of 1? Well, if I want to find f of 1, then I'm asking for the output of this function when I plug a 1 into it. The x-axis here represents the variable x. It's the numbers that are acting as inputs for this function. The y-axis gives me my outputs. So if I find 1 on my x-axis, that's here, and I find where that hits the function, it's at the output of 6. So I have a point here at 1, 6, which means f of 1 is 6. I get it from the y value of that point. We're going to do this 2 more times with different inputs. So f of negative 8. Find negative 8. It's all the way over here. Now, negative 8 is something interesting happens there. Negative 8 is where I have a break in my graph, and I also have some point that's off the graph. So when you see these holes here, those 2 little holes, that indicates that x equals negative 8 doesn't hit either of those. We need to look for a solid point, and that doesn't happen until here. So what is the output of this point, or what is the y-coordinate of that point? It's 7. That means that f of negative 8 is 7. What about f of 4? Well, f of 4, we have another break in our graph, so it's kind of a similar situation as over there, except this time the point that I think I said negative 4, f of 4, the point that x equals 4 takes us to is a point that's actually on one of the 2 parts of this curve. So it's here. I have an open circle here and a closed dot there. That corresponds to 6. So my answer to this one is also 6, like our first problem. Okay, those are fairly straightforward. Let's answer some other questions. Find the slope of the line tangent to y equals f of x at x equals negative 4. So now we're talking about the slope of a tangent line. When x is equal to negative 4, I'm looking here. That's where negative 4 is. And I follow that up to the graph, and I have this point right here. It's difficult to tell exactly what the output of that would be if I plugged negative 4 into my function, but that doesn't matter because we don't need that information for this problem. We just want the slope of the tangent line to this graph. But notice where negative 4 hits our graph, it's on a linear part of that graph. We have a straight line that passes through that point right there. So the slope of this line is going to automatically be the slope of the tangent line to any point on that line in the first place. If I try to sketch a tangent line here, it would look exactly like the line that's already there. So this question boils down to just finding the slope of that line. And the easiest way to do that is to find 2 points on that line that intersect or that coincide with intersecting grid lines in the background. If you notice, like right here and right here, those are points on this graph that intersect these grid lines. So that's going to make it easier to determine the slope. We find slope by doing rise over run. So to get from this leftmost point to that rightmost point, I have to go down 1 unit and to the right 3 units. Down, we interpret that as negative. So that would be negative 1 over 3, or negative 1/3. The slope would be negative 1/3. Okay? Here's a similar problem. Find the slope of the line tangent to y equals f of x, but this time at x equals 6. So let's come here. If x is equal to 6, where does that take us? It takes us up to the top of this little semicircle. Notice this time the graph that I'm looking at is not linear like the previous example, so I can't rely on the same technique that we used here to find the slope. However, in the parent class, we have seen horizontal tangent lines before, which is exactly what we would have here. Notice at this maximum value, my function is increasing, which would give me slopes that have tangent lines that have positive slope. And down here, I have a decreasing portion of that graph, which would give me tangent lines with decreasing or negative slope, which means that between positive values and negative values, I should have a slope of 0 in there. And that's what a horizontal tangent is. So this tangent line will have a slope of 0 because it's a horizontal tangent. Okay, let's look at the next one. Is y equals f of x increasing, decreasing, or neither at x equals 10? Let's find x equals 10. X equals 10 is right here. And the point on the graph that corresponds to is right here. So at that point, is my graph going downhill, uphill, or is it horizontal? Would it have a horizontal tangent? It's pretty clear that it's going downhill if we follow this line that passes through that point. That means that the function is decreasing there. That one's pretty straightforward. This next one is a similar problem. It says if y equals f of x is y equals f of x increasing, decreasing, or neither at x equals -7. So now we find x equals -7. Where is that? Right there. When I find x equals -7, we are at the bottom of this parabola, which would have a horizontal tangent line, just like the other problem over here. When we get to x equals -7, as we go from left to right along this parabola, we're going from decreasing to increasing. So there has to be a point where we are neither increasing nor decreasing because we are changing direction, and that happens at that horizontal tangent. So this one, the answer is neither. It's not increasing, it's not decreasing, it's doing neither. One last problem. We want to arrange these 5 values in order from least to greatest. So in order to do that, I need to know what f of -6, f of 8, f of -11, f of 12, f of -2 are, right? And it's not a simple matter of just looking at their inputs and saying, well, -11 is the smallest number that I see in parentheses, so therefore f of -11 must be the smallest. Nope, that does not tell you that it's the smallest. It just tells me that -11 is the input that I'm using. Whatever the output is, that's the thing that I'm going to be putting in order. So let's find these values. F of -6, going back up to my graph. Here's -6. I want to find f of -6. That is 5. So let's put a little 5 over it for reference. Next, I want f of 8. Let's come back up here. 8 is here, x equals 8. It's right at the corner where this semicircle meets this line right here. I follow that to the y-axis and I see a 4. So 4 for that. F of -11, what is that? -11 is all the way over here. It's on this horizontal line, and that has a y value of also 4. Which I was hoping would not have. I actually meant to choose these so that I didn't have any duplicates, but that's okay. We'll talk about how to deal with that. F of 12, where's f of 12? Even though 12 is the largest input for this graph from what I'm able to see here, it gives me the smallest output. So the size of the input has absolutely nothing to do with the size of the output, generally speaking. At x equals 12, I can see that I'm on the x-axis, which means my output is actually 0. That's the smallest. F of -2. Where is f of -2? Well, here's -2. Follow that up to your function. We had drawn a point there previously. I got a 7 out of that. That looks like it's the largest value. Okay, I'm going to arrange these in order from smallest to biggest. Two of them are the same size, so I can't say, one is bigger than the other. But here's how we can write this. Start with the smallest one, f of 12. And instead of listing these with commas, we're going to use inequality symbols. F of 12 is less than f of 8. That's the next smallest thing. So I'm going to list them in a big inequality here. F of 12 is less than f of 8. F of 8, the next number is f of 11 because these two are the same. So I would say f of 8 equals f of negative 11 instead of less than, because it's not less than f of negative 11. The next largest number in this list is this 5, which corresponds to f of negative 6, followed by this 7. That's the largest number in this list, which is coming from f of negative 2. So that is how I would write this by ranking them from least to greatest. I would use an equal sign here because two of them are equal, but the rest I'm using less than symbols to put them in order. Okay, that is all that we need to talk about. So you should be able to work through the assignment for this week just based on what we saw here. And that's it.